Hello, good evening, and welcome to this evening's webinar brought to you by Texas Instruments Australia. We are very excited to bring you John from the NT, the Northern Territory, Darwin, and from the Northern Territory, John Vayment and Isabel Hoadley. Good evening, John.
Good evening, Brian. How are you?
And good evening, Izzy.
Hi, Brian. Nice to be here.
Terrific, and welcome to the event. My name is Brian Lannon. I'm actually interstate. I'm in Victoria, and I am your host for this evening's webinar, even though the focus is a time shift away from here and a little bit further to the west, where we are focusing on the SACE exam, which of course is used in South Australia for the Certificate of Education, and also in Northern Territory for its Certificate of Education and Training, with particular focus on mathematical methods. Now, you're most fortunate this evening because we have expert presenters, Mr. John Vayment, who is a crocodile wrestler and teacher in his spare time, and a self-described technology fanatic. Bilingual, can speak in terms of TI-84 CE, which we will be demonstrating this evening, and also the CAS calculator TI-nspire. And I have tuned into quite a few of John's webinars, and I always learn something from his webinars because he's such an expert, and he's also always willing to share. Thank you, John.
No pressure there, Brian. Hey, no pressure. And thanks for, I don't know where you found that photo of me, but my wife obviously must have given you that one, so thank you very much.
Yes, that was that was just on the weekend, wasn't it? And I can see the crocodile crying. Crocodile tears, I believe. And new to the webinar scene, and also relatively new to teaching, Isabel Hoadley, also at O'Loughlin Catholic College in Darwin. And Isabel, I'm looking at your bio here. I'm seeing top graduate from the University of Adelaide School of Education, mathematics subjects including essential general and mathematical studies, double major in biochemistry and neuroscience. Wow, we're setting the bar high. Once again, no pressure.
I know, but I wish I had a great cartoon like John.
Oh, look, I'll work on that for the next one. So welcome to you both.
Thank you, Brian.
You don't want to be hearing too much more from me, though, so I'm going to hand over to John.
Thank you, Brian. Well, hopefully you can all see my screen, and good evening. Thank you for joining us. This is our brief for tonight's webinar. And I appreciate it's a busy time of the year if you're joining us live, so thank you very much indeed. Izzy and I were both commenting today how busy it is for us. And if you're watching it on demand, well, thank you also. I hope all of you, both ways, whoever you're watching it, you find it useful tonight. So in the SACE Stage 2 General Maths Subject Outline, electric technology is mentioned about 30 times. And therefore, I think it's imperative that we, as teachers, can fully support and educate our students on the appropriate and efficient use of electronic technology, like the TI-84 CE graphics calculator, in our teaching and our students' learning of mathematics. Now, I love the balance that SACE has given the calculator and non-calculator parts of the exam, and I'm really glad that they didn't go to two separate papers, and calculator and non-calculator paper, like other exam boards. I think the wording of the questions is a testament to the skill and experience of the exam setters. And also I think that in the real world, our students will have to make discerning choices when it's not appropriate to use electronic technology that's available to them. And I think that SACE have got this right. And therefore, we really are addressing that blue comment at the top. So we need to develop these skills amongst our students through the medium their teacher while they're still at school. So they get that support and that learning, so when they go into the big wide world, they're much more technology savvy than perhaps we were in our day. So in the main, the wording in the questions associated with technology are as follows. Words like calculate, decimal places, find, evaluate, and what is. And these students can also be guided by these questions only being given a few marks. Not always the case, but in the main, just a few marks to answer them. And the words associated with answering questions without technology are as follows. And normally, again, those are at least the same marks, if not more, especially questions like where it says exact and show that. And I think those questions are brilliant. I really do. And the follow-through marks that students can get and the reassurance of that they're doing the right thing is fantastic. And I really do praise SACE for that. Where are we at now? So this is what we're going to do this evening, as Brian's already mentioned. As a side note, which has already been mentioned by Brian, if the that's harder than I thought to say that, Brian.
Just say brain.
If any of you have any questions during the live webinar, please send them in via the chat or Q&A window, because the whole point of this is to answer your questions and the queries you have with using this technology to better your teaching and your students' learning and understanding of mathematics. So these are the areas that Izzy and I aim to address through these topics. And with no further ado, I will pass back over to Izzy to talk to us about probability density function, and I'll put my teeth back in the meantime.
Well done, John, and thank you for that overview. I think it is always good to have an overview of any session, so we know what we're lined up for. And Izzy, we're seeing your screen nicely there.
Perfect, thank you. All right, so I'm going to be addressing probability density functions first up. And full disclosure, these questions have been taken from this year's SACE methods exam so that we can give you guys the best idea of what you can hopefully expect from future publications from SACE. So the first question we're looking at is a binomial distribution. You can see the distribution and the expected amount on your screens there. But the thing I really want to focus on from here is looking at the probability, the third question. So the table below shows the probability of k equals 0, 1, 2, 3, etc. Seeds being viable. So what we're looking at in this question is the amount of seeds that we can expect to grow into seedlings. And we're told that 60% of our seeds are going to be viable. So one of the ways that students can obviously do this is to use their binomial probability formula, which they're given in their formula sheet for their exam. However, as you can see, and if you've taught methods before, you probably know this is quite a long calculation, and it takes quite a bit to actually input it into the calculator. So what I want to go through is how we can use the list function under statistics to do all these calculations for us. So I'll just make my screen a little bit bigger so you can see. And we're looking at the list and editing our L1 and L2 to input our binomial probability. So the first thing we want to put in is the binomial probability function, and we want PDF, not CDF, because we want the individual probabilities, not the accumulation of the probabilities. And in here, we're looking at the number of viable seedlings per planting is 8 seeds. So we've got a trial amount of 8. Our probability is 60% or 0.6. And we don't want to put an X value into here because what we want is to see the probability for all of those 8 trials. So if we paste this into our L2, we can see that we end up with our probabilities here. And our first 4 are the same as our table shows in that question. And what we want to then see is what our probability of 4, 5, and 6 are. So just for good measure, we'll also input our K variable here, but I'm going to input it as an X. And to do that, we use stat, we're going to the ops menu, and we're looking at sequence. And we want our variables to be X. We're starting at 0 and ending at 8, because that's our number of trials. And we can paste that in there. And now we can also see our X value as well, or our K values for this question. And what I really like about putting these values into the list is Once students have done this a few times, it should actually take them about the same amount of time to do this as it will take them to do one of these binomial probability questions. And the other thing we can get them to do is then to graph these binomial probabilities. Sorry, I've just got to change my screen around a little bit. Okay, so from here, if we want to graph this distribution, we go into stat plot. I've already got the first one turned on, but I want to make it a histogram. And I want to make sure, sorry, make this bigger again. And we want to make sure our X list is list 2, X list is list 1, frequency list is list 2. So from here, we just want to change the window up a little bit. So I've got my kind of standard window settings. Our X value should reflect our number of trials. So we're looking here between 0 and I'm going to keep that as 10 just so we've got a bit of extra room on that side. For our Y values, if I just go back into this list, we can see that our biggest frequency is at 0.27. So I'm going to make that 0.3 in the window. So now if I go back into my window, I'm going to make the minimum 0, the max 0.3, and I want to set my scale fairly small so that you can obviously see it a bit more spread out. Okay, so now if I graph this function, we should see it really nicely, and I think this gives a really good beginning understanding for students when they're looking at that normal approximation to binomial. Because if we increase our number of trials, we can see obviously our functions are going to become more symmetrical, and that kind of introduces that concept really nicely, I think. The other thing that I've just put on my slideshow here, the steps that you need to do that, so I'll just go through that, and if you want to go back and look at it, you can. And there's the window settings as well. And the other thing I really like about having this set up in the list is that what students can do is, instead of using the binom CDF function to find the probability, they can actually use the sum function in statistics. So if I now quit from this and say we want to find our binomial probability, so CDF, oops, sorry. So the CDF, and we want to find out of our 8 trials and our probability of 0.6, we want to find our X value where it's less than or equal to 6. So if we paste that in now, we can see we get a probability of 0.89. But we can also do this using the, sorry, I was in the right menu before, the sum function, which is under math in the list. So if we go to sum, and we input our list 2 because we want our accumulation of the probabilities from that list 2. And we're looking at between 0 and 6. So the only thing that students need to be careful about with this is if I go back into the list menu. Oops, sorry. So if I go back into here, our first value, which is when our X value is 0, is in our first position in the table in L2. So even though we're looking at the accumulation of probabilities from X values from 0 and 6, we're looking at the table positions between 1 and 7. So we're just looking at the n+1 position in the table. Okay, so we're looking at the sum from L2 from 1 to 7, and you can see that that probability is the same. And what I think is the advantage of doing this is that a lot of the students, I think, have misconceptions with using binom CDF when it comes, not so much for doing less than values, but when it comes to doing greater than values, where they have to input the 1 minus the binom CDF to find the probability that it's going to be greater than a certain amount. And by using that sum function, we can actually work out the greater than probabilities without them having to work out what their question's actually kind of asking them to do, I guess, as in such a difficult way. So if we wanted to do this, I'll just quickly, we go into binom CDF again. Say we want to find the probability that it's, oops, sorry. So say we want to find the probability that where it's greater than 6. we can just input that again. So this would be probability of 8 and 9. So we're going to have, oh, sorry, guys, I keep doing the wrong thing. So we've got our 8 trials, 0.6, our X value still being 6 if we're finding greater than. We can enter that in and we get this 0.106 probability. However, if we wanted to do this using list again, we can still use that sum function. And we're looking again at L2. And in this case, if we're finding greater than 6, we're looking at the 7th position and the 8th position. Oh, sorry. I think it's using this big screen that's making me confused.
Do we count the 7th in there?
No, so we're going to look, sorry, we're looking at the 8th and 9th, because the 7th, and so I've just done exactly the thing that they're going to get confused with. So if we're looking at between the 8th and the 9th, which would be the 7th and the 8th, we end up with the same probability again. Okay.
Izzy?
And I think, yeah.
Going back to that with that computer screen, if the students do make a typo, you can actually just arrow up. So if you arrow up 4 times now until the one that you typed in wrong before, the 7 and 8.
Yeah.
So then if you press the arrow on the handheld.
Yep.
And then go up 3 times and then press enter again.
Yep.
Then we can go back in, we can copy and paste, and we can actually go back into it.
I know. I just do something wrong and then I completely forget what I'm doing. Anyway, but thanks for that, John. That's really handy. Okay, so the next thing I want to look at in here is continuous probability density functions, which is something that's reasonably new, and it links in quite well with using integration and probability. And so it makes that nice connection between statistics and calculus. And what this question is saying is the graph below represents a continuous probability density function defined for between x is 0 and 4. And the probability density function is f of x equals a. So we find that our value of a is 1/4. And then they're asked to write an integral expression for the mean of the distribution. So we can see that's going to be x multiplied by your a value, and you're using your integral. So if students then went and took the integral of this, inputted 0 and 4, that is, again, quite time-consuming. But what we can do is use the calculator to calculate it for us, and it's only a 2-mark question, which, like John was saying before, and it says evaluate as well. So that would be an indication that they can definitely use the calculator for this kind of a question. So from here, I'll just clear that to make it look nice. We're looking at using the integral expression, which we can find in alpha F2, so under function. And I'll just point out for John later on that there's also this derivative function under alpha F2 as well. But we're looking at the 4th one, which is the integral expression. So we'll put that in. Our bounds are 0 and 4. And we want to input that quarter, and I'll just show you how to do it as a fraction. Obviously, they could use 0.25 if they wanted to, but just to make it look nice, you can also find your fraction input under alpha F1. So if we go into there, we'll make this fraction a quarter. We're multiplying it by x, and we're taking our integral of that x value. So we can enter that, and we get our mean of 2. And it's much the same for the next part of this question where they're asked to find the standard deviation. So again, they can still use that integral expression. And I've just got up on the screen for you what it should kind of look like in the calculator, but I won't go through and do it because it's just the same thing again. And John, I think I'm done, so back over to you.
Fantastic. Thanks, Izzy.
Yes, thank you. Again, looking at things, multiple representations, I think, is a great way to go. I really like the use of the probability density function, but I hadn't really thought of using it for the summation of lists there. So that's just another way of showing the same thing, which I think is quite clever. John, we can see your screen.
Thank you very much, Brian. Like Izzy said, I think that since we're reflecting on the year that was, I think it is quite poignant to use some of the exam questions. We know that other resources will be using the same, and it's just there to support teachers to really understand what's going on. And this is question 3B. Here, I would encourage my students on this question to do it without a calculator because of the number of marks on it. It does say solve, so really you could argue that it could be done by the calculator, but I think that the 3 marks encourages students to do it by hand, and that's the way that I'd encourage them. But as I mentioned earlier, that you would still want students to just check that, is that answer correct? Is the answer I get? And that's a really important thing. One, it just makes them feel better. They go, whoa, yes, I got that right. That's fantastic. And they go on and attack the next question with a much more positivity. So the answer they should get is a quarter, if I've done my maths correctly. But we know that we could actually get them to type it into the calculator. Notice there's a typo there. I added an extra bracket, which I shouldn't have added. So that was a bit poor on that one, but just notice that now. But if we did it correctly, then we could actually then graph it, and we could find the 0 in second calc, finding the left and right bound, and therefore we can see there that it is a quarter, as it says in the question. And the other way is to add a y equals 0 line. I quite like this approach a little bit more. The reason I like this is because students really understand what that x-axis is. So I quite like putting the y equals 0 and then doing intersect, which actually does it probably a little bit quicker as well, where you could just go intersect and press enter 3 times. Notice I have changed my window because in the question does say that x is greater than 0, and I encourage my students with a question like that to actually set their window up so they don't get confused. We know there is likely to be another value. I think it's negative a quarter on the other side, but we're only interested on the positive values. So moving on, question 4B, again, is a great first principles question. Love these questions in the exam. I'm not sure my students do, but I love seeing them. And question 1, the slope, I think, can be reinforced or helped done on the graphics calculator, and definitely their answer to the first principles can be confirmed using the calculator. So I, again, encourage them always when they see an equation, so we can see that in the question, it's fx equals 4x on x plus 1, to graph it. And to get it looking like the picture, there's nothing worse than the graphics calculator not having the same sort of view as the question. And what I thought would be quite a nice way, we could actually do value like we've done in the past, but we can also do it a different way. Firstly, we can check that the derivative in the normal calculator screen, and that was using the second calc function that Izzy talked about, can be used to see what's going on. Sorry, alpha F2 to see the derivative. So we can do that to find the exact value. And notice that we would talk to students about how that there is slight rounding error with the calculators, there always is with technology, and that really, although this has all these zeros and 6.4, the 6.4 is not really there. It really is just 0.16, and we can see that the answer they should get is 4/25. So that's that part. If we then move on to question 5, this is definitely a question that in the exam students can't graph because it just says y equals gx. Again, fantastic questions. Students straight away go, well, I can't graph that. I've got to understand, just work with it and understand it and interpret it, which I think is really important. But in the pre-teaching or the pre-learning of this sort of question, we can use technology because we can come up with a question very similar, or reflection for future years. Perhaps for next year we could say, well, look, you know, this is what this question was really talking about. Here's an equation of one very similar that I've come up with. And what we were asked in this question was to look at the second derivative and at certain values and the first derivative at certain values. And what we can actually do is we can graph the derivatives. So you can see that there's the equation that is very similar in Y1. And using the alpha F2 key again, like Izzy showed earlier, we can actually get the first derivative, and then I also can get the second derivative. I may just show, because there's a comment that's just come in on how to do that. So I'll just keep that to the side. I should have shrank that down, but I didn't. But since I've just changed what I'm going to do.
I've just put that into the chat, and somebody came back and said yes, they would love to see that. So thank you.
Yeah. So I'll just do it now with that. So let's look at my calculator. Let's move my calculator to the side so we can see it. All right, come on, grab it. There we go. Okay. So I won't do the actual same question, but let me do one that's very similar. In fact, I'll just do perhaps that cubic part. So negative, let's clear that first. Negative is a fraction, so that's alpha F1. There's the fraction button. Love this functionality. Like I said, the designers and the programmers have worked hard to get this. I always say to my students, well, you know, they worked hard to put it into the calculator. You should definitely be using it. And it's the same on the TI-84 Plus as well.
Yeah.
Cubes,
yeah, the
power of 3.
Template and the wizards that Izzy was demonstrating, it's just made this thing so much easier to use than its earlier operating systems. That's
right. So then in the second one, as Izzy showed you a minute ago, we go alpha F2, and there is the derivative one, so number 3. And we choose derivative with x. And yeah, we could type that in again, which would be a bit silly. It's not so bad with this one, but I could type this whole thing again, but I can't be bothered. In the old days, we used to have to go into vars to find y1, but now in F4, there's y1, much quicker. And we're going to find it for all values of x. And as Brian mentioned earlier, this is not a CAS calculator. It's not like the Inspire CAS. But so we're actually getting numerical values that it's then dropping points, dropping a lot of points. So I don't think it actually will be an issue for us. Again, back to F2. Again, if you press the wrong one, it doesn't matter. Just keep pressing across until you find the one you want. Over time, you'll learn which ones are which. And that is as simple as that to draw the, oops, sorry, too many tabs down the bottom. As simple as that to actually get the graphs of them. And it probably won't show very much. I'll just go zoom standard just to get an idea of what that may look like. And we can see that it draws it pretty quick. And again, I love this fact here, even with this simple one here, that where you talk about how this is a cubic, the first derivative is a quadratic, and the second derivative is linear. Like, that's just a great visual of how that works. It's just fantastic.
Yep. And, John, I'm just also thinking if people do want to compare this to the TI, if they have to go non-CAS, as we're looking in Queensland, the TI-nspire non-CAS calculator can do these, has these same features. So the same tricks can be done on. Yep.
Yep, very true. So this question here was another graphing one. This is question 7. And we can see that this time we are given an equation. So straight away I would encourage my students to graph it. And it gives us a window on the x, so they would just have to play a little bit with the y value. But we can see that we pretty much get it spot on. Notice I've set my x scale up to match exactly the values on here. So again, it looks as much as possible like the real thing. And in the question, it was talking about finding the heights of the rectangles. And I was thinking, well, how can we do this? Well, using the calculator, we could use value is one way we could do it. But another nice way is using this functionality. So I will just show this again because this leads in quite nicely with the same question. And I should just shrink it down, shouldn't I, Brian, rather than keep going this way. But there you go. I'm going this way now. I don't want to save those screenshots from earlier. So we go into here now. Let's clear all those out from earlier. Okay. And we've got x e to the negative x in a window, like I said, from 0 to just over 6. So let's go 6.3. Oops, not 63. Going up by 1. And the y min, well, that's a 0. And, well, what's the height? Well, it's looking like it's at 1, and e to the power of negative 1 is 1 over 2.7 blah, 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 times 1. So, Brian, any thoughts what that's going to be? 1 over a quarter.
About a third.
About a third. So let's go, say, 0.3. How are we going? Ah, look at that, just a fraction more. We could find that out by either going max or going to table. There we go. I like the table myself, so we go to a max there of 0.4. oops, that was silly. 0.4. So easy. It must be catching. I'm doing it as well. There we go.
There we go.
And so, yeah, so to get those values that we just talked about, yes, we can go second calc value and number value at x equals 1. And there's the same number. We can see that that number there matches exactly with this number over here. Please be mindful that these numbers are temporarily stored, or not even temporarily, they're stored until they get wiped over again as the variable of y. So actually, we could actually quit that now, and if we go and get alpha y, that same number comes up. It's a really nice little feature. When you see students writing down this long number to use later, or they don't use the exact number and they get a rounding error, it sort of breaks my heart. So there's a nice little feature. And because y is constantly changing when we do new calculations with x and y, I would then store that as a different variable. So we're going to store that as a. And we want the second value at 3. So like I said, I could go back and do value the same way again, but this time I'm going to do it differently, a bit like how we would do a function. So we're going to go y1 bracket, so it's the graph at when x is 3. So it's a nice little thing for the students to think about as well. And then also we're going to store that as a variable, different variable, we'll call it b this time. And I do encourage my students, if they're using this store functionality, to actually write down what values they've stored as the letters. So up here I would get them to write A, and up here I would get them to write B. That links in quite nicely that when students are doing practice papers, I really, where I can, I know it's not always easy, but it's to get them to have a copy of the exam paper they can actually write on when they're doing practice papers, because I encourage them to do it in the exam, but if we don't give them practice to do it before the exam, then under the stress of the exam they won't. They'll forget that. So again, then now we can simply do the first value plus the second value, and it's the width of 2 for each, and we can see we can get the same answer. There we go. Very nice. I like that. All right. So that's that one. And the second part of this question was to find the exact value of the area. Again, we were saying that, well, to do the exact value, you're going to have to do integration between bounds 1 and 5, and fair enough, it's a 3-mark question, and that's no dramas. The answer they should get is this when they do it by hand. But again, well, that's okay, but we can at least check it to make ourselves feel good that that should be the right answer. So that's the decimal answer they should get. Because we've already got that graph, then we can quite easily just do, as Izzy showed earlier, the integral between 1 and 5, and see it's the same value. And again, they move on to the next question feeling $1 million that they're kicking goals in this exam.
Which they've just done for the confidence, though, John. They've just done that to reassure themselves. Most importantly, they don't write down, they don't record the decimal answer, the decimal approximation as their answer for that question.
That's right, yeah. So when I actually, when I get the students to go through these sort of questions, I get them to highlight or underline the word exact value so that, the answer they should be giving is that 2e to the 5 fraction. This is just more a checker. And then we've also got that nice visual checker as well that we can do in graphics calculator mode using second calc and doing the integral between 1 and 5 that way as well.
Mm-hmm.
So question 14 into book 2, and I hope the markers are finding it okay to mark all these questions. I know it's a stressful time for them, so I hope that they've gone well with marking them, and it's quite funny that now the stress has moved away from the students who are now relaxing and enjoying themselves to the teachers and thinking about next year, which is what we're all reflecting on this year and thinking about next year. So question 14 is a lovely question. Love this. I love it when we look at history, and again, if I was doing this next year, I'd get the students to look up Jean-Baptiste Joseph Fourier, if I pronounce that right. Sorry if I haven't. That's my best French accent.
And you need to be wearing a beret as you say it.
I was, actually. I was.
Okay, of course, yes.
Yeah. I think that looking at the history of that, like the SACE have given it a context, and therefore we should actually get the students to learn about that. I think there's nothing wrong if we can find time in the Year 12 course, or even perhaps if you're doing a transition time with the Year 11s, to look at that mathematician and what he did find out. I think it's really important, and perhaps students can learn a bit more about that. But this question again is predominantly non-calculator. There's a hence, there's a find the derivative. So it pretty much is non-calculator, and in fact it's moving on to, if I remember rightly, making a conjecture and justifying a conjecture. But I think that the graphing capabilities of the TI-84CE with the colour is worth showing off on this question. So here, there, I've typed in the 3 that we can see. Notice again, I've been lazy or efficient. I quite like saying students lazy. I think they appreciate the word lazy more than they do the word efficient. They go, oh, yeah, I like being lazy. I'll do that too. Yeah, notice I've just done y1 plus the next sign value, and equally y2 done the same. And then it looks like this. Now, obviously pretty messy having them all on top of each other. If this was on the 84 plus, it really would look like a very thick line, one because of the pixels, and also is this all the same color. So it's much nicer on here, but we could change the window, and that gives us a really nice idea of how we can see it a bit clearer and how it's actually changing each time and how it is shifting, or the similarities equally. But also what we can do is in the original graph, we can go over the equals button, and we can actually change it by pressing enter on it. We can change it from a black square to no black square, or rectangle, should I say.
Switched off.
And that basically turns it off. Doesn't delete it, just turns it off, and therefore we can see that only the second one is being graphed. So if I just scroll back to the other slide, we can see that here all 3 are highlighted, so therefore all 3 graphs get drawn, and we can equally see that here only the middle one's highlighted, so that we just get that graph. And yeah, there we go. My students enjoyed the paper. I hope your students did too. I hope you've enjoyed teaching the course, and you do so next year. And Izzy, that's enough from me. I'll pass back over to you. Thank you very much.
Okay. That sawtooth picture is fantastic. I know it's an exam question, but given more time, isn't it just itching for you to just play with it more? Do the next iteration and the one again, and keep going until it is a true sawtooth without the the vibration in it.
Yeah, I think it's definitely something that hopefully I would like to find time to look at, whether it be with a current Year 11 class, or if you could find time with a Year 12 class, or equally, like I said, with a transition group where you're sort of trying to give them something different without sort of going too heavy into things. And I think it's a great question, and what a lovely way to finish the exam. He says, having not sat it.
Good on you. So, yeah, thanks, John. And Izzy's going to take us out with the confidence intervals, proportions, and normal distribution. We can see your screen Izzy.
Excellent. Well, thanks, John. And yes, we're back onto statistics, which is very exciting. So for the last bit, I want to talk about confidence intervals, and I'm just going to go quickly through finding confidence intervals for binomial and also for normal distributions. So this is actually the same question I was looking at before with the plants, but you can see the bit that's in red there is asking you to find the confidence interval. So the way that we can do this on the calculator is to go into our stat menu, and then we want to use the tests function. And for binomial distribution, we're looking at this alpha function, which is our proportion interval. So in here, and sorry, I've already got it put in there because I was just going through it quickly before. So we have our X value, which is 53, our sample size, which is 100, and the question is asking for the 95% confidence interval. So from here, we can then calculate, and we can see there that the proportion is actually the same as the question above, which students should have already calculated, but that should give them a nice kind of reassurance that they've done the right thing in the exam. And from here as well, we're looking at our proportion, and we can see that our 95% confidence interval is going to lie between 0.43 and 0.63, which is lovely. just to compare, we'll go through one where we're looking at normal distribution. So again, this is another question from the exam. And just so, because you don't need all that information there, I'm just going to make this screen a little bit bigger. And instead for normal distributions, we're still looking at the test menu under stat, but we're looking at our Z interval, which is function number 7. So in here, we want to make sure that we've got our stat highlighter. I've just gone into data so you can see, but obviously we're not using the data from the list to calculate our confidence interval. So we want to make sure that we're inputting our own statistics. Our standard deviation for this question is 2.5. Our sample mean is 17.4. We've got a sample size of 80. And we're actually looking at our 99% confidence interval for this first question. So if we then calculate that, we can see that again our interval lies between 16.7 and 18.1. So they're just the two different ways that we can calculate confidence intervals on the calculator, and students are also given formulas for those in their sheet at the start of the exam if they need it as well. The last thing that
just to confirm as well, obviously we've got to make sure that when students see that last answer that's on the calculator, they don't just write down what they see. Yeah, that's the problem. It doesn't come up as a history, does it, when you do that? But thank you.
No, it doesn't. That's okay.
When they see, so I'm going to make you work again. When they get their answer on the graphics calculator, that they don't give that on their answer sheet as in that form. You know, if they write down bracket 16.68, comma 18.12 bracket, they're not going to get the marks. They may actually even get 0 marks because that's calculator speak. It's not actually what the question's asking for. It's asking for the bounds for the mean. So it's very important that they just understand it's using it to support their answers almost.
Yeah, so they still want to give their answer in the form that it's written in their formula sheet on their exam. So they still want to have, for this case, the mean lies between those two values. Not written as an interval as such as it is there. But again, if that's something that if you introduce quite early, then students should be familiar for that when they come into their exams. Okay, so the last thing that I just want to talk about quickly is using inverse normal on the new operating system, because it is slightly different to what the old operating system has. So I'm just going to change my screen back, and we can see that this is the example question that I've chosen. So the heights of adult males in Perth can be taken as normal distribution with a mean of 174, standard deviation 8 centimetres. The West Australian Police Force only accepts recruits if they are at least 180 centimetres tall. However, they want to change their minimum height so that they can accept a quarter of the adult population. So what's different about using inverse normal now with the new distribution, with the new operating system, is we can actually select where our proportion lies. So whether it lies on the left-hand side of our distribution, whether it lies in the centre, so neither the left-hand side nor the right-hand side, or whether it lies to the right of our distribution. And this is nice because it means that if students are finding a greater than amount, they again don't have to do that 1 minus the inverse normal to find it. So for this one, we're looking at the greatest quarter, so 0.25. Our mean is 174. Our standard deviation is 8. And we're looking at the greatest right-hand side of our inverse normal. So if we paste that, we can then see that our minimum height is going to be at 179 centimetres as opposed to 180. So not a big difference for the West Australian Police Force, but still means that they can accept a few more people.
Izzy?
And, yep.
Somebody just asked, how do you find out on your calculator or equally on the software what operating system you're running?
Oh, okay. So to find that, John, you're just going to have to help me on here a little bit.
Second mem. So second down to memory, which is the plus key.
Yep, that's it. I can never remember whether it's in mode or memory. And then we find, sorry, I just did this the other day, so I should update mine. And
There it is, 5.3. And that's the new operating system. The regular updates get sent out by TI when they're available, and you can also find them on the TI Australia website. I find sometimes the students, some of them will have the updated operating system, but equally it's very important that teachers have it on their smart view. And that's very easy to do. Again, the website shows you how to do that. And as a little plug, if people do want to know how to do it on for the smart view or their handheld, our webinar last week, which is now on demand, people can actually look at that and see how to do it from the last week's webinar.
Yeah, and it's one of the big advantages as well, John, of having TI Connect, isn't it?
That's right. Yeah, definitely.
Yeah, TI Connect and of course the software that you've both been using there, which is the Smart View, which can also allow you to, if you're doing programs, to store those on your computer and add them to the calculator, which is, you can see the little green icon on the left, which is highlighting at the moment the calculator on Izzy's screen, but just below that is a magnifying glass, and that's where, if we open that one up, that's where you can drag and drop other files in to the calculator, including photographs as well. If you've got a photograph that's anywhere on your computer, you can just quite literally drag and drop that photograph into this screen here, and it becomes one of the images that's available to be called up in the calculator. Of course, you can also connect a calculator, as John mentioned, through TI Connect, and copy those across to student calculators. You know the deal from there.
Yeah. And the other thing we also did last week in the general maths webinar was we took Excel spreadsheets across as well, where we had lists of data saved and went through saving that into the list of data on the calculator.
Yep, absolutely, very powerful. Australian Bureau of Statistics website, I think, is just a classic that I know I'm one of many teachers that use that one for the sources of data, to be able to just quite literally drag and drop into your calculator. That's so powerful. And again, once again, also can be done seamlessly on the TI-nspire platform if anyone is using that one instead. So thank you both very much for your enlightenment and clever ideas this evening.
Brian?
Yes, John.
Sorry, Izzy, was there one more thing that you wanted to talk about? Sorry, I thought there was something else that you wanted to finish off with.
No, I think that was it, unless you have anything else you want to add in, John.
I think the only thing I'd like to add is that I've noticed that quite a few of our attendees tonight are from Queensland, which is awesome. Thank you for joining us. We feel even more honoured, considering that it was talking about SACE, but hopefully you found that useful for your exam board as well, because really at the end of the day, most of these questions are just straight maths questions. They're applicable to whether it be IB or different states or any international exams. It's more about maximising its use on the calculator. But as Brian starts wrapping up, if any of you that are watching tonight do have any questions, please do urge you to send them in, because we are here to answer your questions. So yeah, please send any questions that you do have into us.
Yes, certainly. And I thought that too, John, that Queensland teachers might be looking at tossing up either between the TI-84 CE or using the Inspire non-CAS. So if they're working on a non-CAS platform. And of course you have put, and now Izzy, have put lots of materials up on the web already through our webinars and also through our student support materials and teacher support materials that can be applicable for those. Just talking about the website, I just thought I'd quickly overview that there. For the student support in student resources, so this is the Texas Instruments Australia website front page. If you then click on the pull-down tab on student resources, getting started is, I've got this new calculator, how do I use it, that can access tutorials. But more exciting is this prepare for exams which is set up for state by state. So here you see this is a whole new series that was set up for Victoria, video questions series. So that's small videos that are also on YouTube. Here's Queensland using the TI-nspire non-CAS and the TI-84 plus CE, which both John and Izzy were using this evening. And here we have South Australia, Northern Territory, and you can go further west if you wish. But I think that's just a terrific resource for students. And for teachers, I expect you've already found it. Of course, in the professional development, you can access this webinar later on under the not upcoming webinars, because there are no more upcoming webinars for this year. So well done to the participants tuning in tonight, this late in the year. But here we have the archive of our previous ones, where you can, as you can see, select the technology, select the level that you're interested in, and there are many to explore. Just before I do finish up there, the other big part of this site I like is the Australian Curriculum Inspired and Senior Curriculum Inspirations. And that's where, once again, select your state, South Australia NT, select your course. There's featured activities and topics. And what a lot of these are is there's worksheets. So you've got a student worksheet, another worksheet with the answers written in and some teaching tips, and in many cases also some supporting calculator files.
Brian, while you're on that page, yep. I have to say that I know that you've got it down as specialist there on the website, but that's a great activity that Peter Fox has produced with the filling the vase one. I highly recommend that one on both the Inspire and the 84. It's just a great activity and a great one that teachers can do practically with their students as well.
Yeah, I thought he was also very clever there in utilising YouTube clips. You know, we've got these videos available. It's up there. Access it and use it for your investigations. I'm looking at the time here, and we do have to finish up. So thank you once again very much to both our presenters this evening. Isabel?
Thanks for having me.
Terrific. We hope that we can have you again with these. And you were part of last week's webinar as well. I haven't viewed that myself. I was away at a conference, but I'm keen to have a look. And to John, the crocodile wrestler.
Thank you all. Thank you very much for joining us, and thank you, Izzy. Great work. Thank you, Brian, for giving me the opportunity. And as I said, this is the last webinar for this year, so you will see this team back again next year. So keep checking that website, and of course the newsletter that I'm hoping you're subscribed to. Following this webinar, you will get a follow-up email within the next couple of days, included in that, so useful links and information and a link to the on-demand webinar, your PD certificate for joining us. When we exit this evening, you will be taken to the feedback page. Thank you very much for your comments there, because we do review, and of course that's going to be happening right now as we will be reviewing this year's webinar program and looking at ideas of what teachers want mostly for next year. Here is your opportunity to have your input. And I mentioned before the YouTube page, that's the Texas Instruments Australia YouTube channel. There's a lot of short clips. When I say short, 4 or 5 minutes, that can be useful just on a tip for an idea and also for students. So I highly recommend that one. I've already mentioned our newsletter, which I also highly recommend. And talking about recommendations, if you do have any remaining questions, either from this evening or any other of your Texas Instruments technology concerns, these are the phone numbers to ring, and
I don't know about New Zealand, but I do know the people who answer the phones in Australia, and they're pretty switched on, and so they're probably worth giving them a call, even if you just want to phone them and say, hey, thank you for the wonderful support you're giving us. So we will finish with that. Thank you to our participants. Thank you to our presenters. My name is Brian Lannon, and I wish you all well. Cheers.
Good night.
Good night.
Night all.